You're welcome to our physics class today, and in physics we shall be looking at the topic friction and viscosity. So what is friction about? Friction is a force that acts at the surface of separation of two bodies in contact and tends to oppose the motion of one over the other. Now what we mean is this: we have a body such as this, and let's call this body A. This body is at rest, and so no friction on this particular body. If you tend to pull this body, now you will realize that this body will not move instantly. Why? Because there tends to be something between the base of this body A and also the floor. Now it depends on the material in which the surfaces are made of. There is going to be some form of friction that will not permit it to move at first. The force that is not making it move in this direction as fast as we want it moves it in the opposite direction, and that opposite direction here is frictional force. It is basically a force that acts at the surfaces of A and the surface of this ground. It opposes the motion of this one, A, over G, which is the ground. We have two basic types of friction. We have what we call the static or limiting friction, and number two, we have what we call the dynamic or sliding or kinetic friction. Now we need to understand the concept behind these things. Now when we talk about static friction, now let's take this body as an example. You have a body like this, A, on a surface G, and you have a force P which is pulling the body, a gradual pulling of A. To know the intensity of the pull, a spring balance may be attached here. So when a spring balance is attached there, you'll be able to detect the quantity of force which is applied to pull this body. You apply the force slowly, you find out that the body may still remain at its position. It will not move immediately. Continue to increase the force, and when you increase it, you will get to a particular force in which the body A is about to move. You find out that if you apply a little more force, the body will begin to move. So before that body moves, the maximum frictional force that stopped a stationary body from moving is called the static or limiting friction. We could use Fs to denote static friction, and then we have what we call the dynamic friction. When you hear the word dynamic, it talks about something that is changing, moving, that has some kinetic energy there. So let us take that this body, we've applied some force, which is the P, and the body has started moving. We keep applying the same force on this body, and it began to move uniformly. So it has a uniform motion. There is still a force which prevents the body to move in equal proportion to the force which you are applying to it. That force is called dynamic frictional force. So considering a body like this body A has its own weight, which is W, and weight is equal to mass times gravity. Now to every action there's an equal and opposite reaction. Now this body has a force that is also making it to be in equilibrium, and that force, we will call it the normal reaction. The normal reaction is the equal and opposite reaction to the weight. So R is equal to W. When we apply some force to this and it begins to move slowly, the frictional force acts on it in the opposite direction, and then the weight to some extent. But imagine when we increase the weight over here. Let's say that we add another weight to this. We will notice that more force will be needed to pull this body to the right direction that it's going to. As it increases, we'll find that the weight which has increased has led to the increase in this, and as this increases, this also increases. As this increases, we'll find that it has an effect on the frictional force, and so this would lead us to saying that when more load is placed on this A, the normal reaction will increase. So does this Fr. Now the Fr here is going to be Fs, which is the static friction, will also increase, and so we will call it that there's a proportional increase between F and R. Now this proportionality is being replaced by equal to, so F equal to coefficient of static friction times R, and don't forget that R equal to W, that's normal reaction equal to weight, and weight is also equal to mass times gravity, and we are having that F equal to mu equal to coefficient of static friction and R. So we could have it that coefficient of static friction is equal to F over R. And so we look at the laws of friction. The first law says that friction opposes motion. So just as we've seen, as we are pulling this body, there is a friction that is opposing its movement in that direction. Number two is that it is independent of the area of the surfaces in contact, and then it depends on the nature of the surface. So if the surface here, if the surface of this one is rough, we'll find out that we will have so much of frictional force that will be limiting air from moving in this direction. But if we have smooth body, whereby this ground is smooth, likewise the surface of A is smooth. Now if it is completely smooth, we may even have a zero frictional force, that is, whereby there is no force, and any small force that is applied to move it in this direction will lead to the movement of this body over G. And then we have number 4, saying that it is independent of relative velocity between the bodies. So frictional force is independent of that, and also we have that frictional force is proportional to the normal reaction. So which is this: the frictional force is proportional to the normal reaction, and we have this equation. Then we have that the coefficient of static friction equal to frictional force over the normal reaction. Now once we look at viscosity, viscosity is a name that is given to the internal friction which exists between layers of a liquid or gas in motion. If we have a pipe, and in the pipe water as a liquid flows in this pipe, we would realize that there is going to be friction between the surface of this pipe that's around it with the molecules of the water that's moving. Now the friction around the internal surface of this pipe is more than the friction at the middle. There's going to be more limiting force over here than here, and the viscosity between liquids are different. For instance, let's consider glycerol and water. So glycerol is going to have more friction than water. Now let us consider this. Let's take this as a liquid. Now, and in this particular liquid, we drop the ball. The ball has its own mass. So we have it that the ball exerts a weight which is equal to mass times gravity. When you drop the ball into the liquid, you find out that yes, while it was dropping from the air, it was faster. But when it enters into the water, the speed by which it moves will reduce. And why has it reduced? It has reduced as a result of the upward force, upthrust, and it has also reduced as a result of the viscosity. These are the two forces that reduced the movement of the ball. Now, when we consider the upthrust, the upthrust is the liquid that is displaced. So as you drop it inside, there's an amount of volume of liquid that will be displaced due to introduction of this ball into this liquid. And then we have the viscosity, which is the internal friction between the surface of this ball and the surrounding molecules of the liquid that is there. So we have it that now for this body to continue to move downwards, the weight, which is mg, would have been able to overcome these two forces, which is u plus v, before the body can continue to accelerate. Mind you, while the body was outside falling, it had its complete mass times gravity. But when it entered into the water, the gravity would reduce, and then it will reduce into the acceleration which it will have. And the acceleration is reduced due to all this. And so the body will continue to accelerate depending on the liquid that we are talking about. It may continue to accelerate, or it may reduce acceleration and begin to move uniformly. Now when we say that it accelerates, that means that it continues to fall faster. But after some time, to not have that acceleration again, and then it will be falling at a constant velocity, which is uniform speed. Now the uniform speed by which it now begins to move is known as the terminal velocity. So the terminal velocity is as a result of the fact that the ball which was falling inside this liquid is no longer accelerating. And so we'll have it that the v is proportional to the speed. So where this v represents the viscous force, and then we have this V as the speed. So we have it that V is equal to K small v, where this K is a constant. Now at that point, we will realize that since it is no longer accelerating, that is, acceleration has turned to 0, we have it that this particular equation will become 0 equal to mg minus u plus v at this particular point. Number 1. A body of mass 5 kg is placed on a horizontal plane. It is found that a force of 10 Newton applied horizontally to the body is just about to move it. Calculate the coefficient of starting friction between the body and the plane. So we have it like this, that we have an horizontal plane and we have a body which was placed on it. Call it A. It is found that a force of 10 Newton. So we have a force which pulls it, which is 10 Newton, applied horizontally to the body so that it is just about to move. Now that means at that point, what we have there is the static friction. So we have the static friction over here, meaning that this 10 Newton is what is needed to overcome this maximum frictional force. And so we'll have it that this particular pull, which is the 10 Newton, is equal to the static frictional force. So we'll take our F to be 10 Newton. And we're told that the body has a mass of 5 kg. So we have it that our weight equal to, that's mass times acceleration due to gravity, mg. M is 5 times 10, that gives us 50. We're told to find the coefficient of static friction. So in this case, we have it that coefficient of static friction equal to F over the normal reaction. So we have a weight here and we have a normal reaction here. And we have that the weight is equal to the normal reaction. And so the coefficient of static friction, where our F, that's the static frictional force, is 10, and then the normal reaction over here is 50. And so we have 0.2 as the answer. Take note that coefficient of static friction does not have a unit. Why? Because the unit of friction here is Newton, the unit of the normal reaction here is Newton, and so they cancel out. So we have this as our final answer.